Hello, today's topic is going to be simple harmonic motion and the team members are
Manuel Hermosillo,
Roberto Macías,
Manuel Abitia,
Santiago Rubio.
and your server García.
Now I'm going to talk about the definition of simple harmonic motion. Well, it's any motion where a restoring force is applied that is proportional to that displacement and in the opposite direction of that displacement. Well, in other words, the more you pull away, the more it wants to return to the middle. An object is in simple harmonic motion if the acceleration is always directed towards the equilibrium position. The classic example of simple harmonic motion is with the use of a spring, because the more the mass stretches it, the more it feels being tugged back towards the middle. As the spring moves towards the middle, its kinetic energy accelerates and increases. However, when the spring is at the edges, the energy is converted to potential energy since there is no movement.
Each time your heart beats, your blood pressure increases, then decreases as the heart rests between beats. A certain person's blood pressure is modeled by the following function, where PT is the pressure in mercury meters at time t measured in minutes.
Now I'm going to show you the sine function. As you can see, A equals amplitude. In our formula from the problem, we got 25. K is a constant number. In our formula, we got 160. I want to emphasize that for obtaining the period, the formula is 2p over k, the constant number. B is a phase shift, because we do not have any extra number in our formula, so we do not have a phase shift. C is a vertical shift, and our formula is 150. First, we're going to calculate the amplitude. For the amplitude, we need the value of A. Important, absolute value of A. So, okay, the absolute value of A equals 25. Okay, now I'm going to show you how to calculate the period, which formula is 2p over k. In our problem, we got as k 160. So, in here, I'm going to... We got 2p over 160p, which result is 1 over 80. Okay, since each period represents a heartbeat, so we got 80 heartbeats per minute as our frequency.
with the formula we know that the starting point on the y-axis will be 115. Being a sine graph, we need to know the 4 points to know the highest and lowest points of the graph. So as needing 4 points, we divide our period by 4, resulting in 1 over 320. Due to this, we have these numbers on the part below. After this, we know that our amplitude is 25. So it will rise 25 on the first point, and then decrease 25, and then decrease another 25, and then rise 25.
Since the heartbeat is faster, the period becomes shorter. Therefore, the period will be completed in less time. Since period and frequency are related, frequency will be decreased. However, exercise that is good for your heart should elevate your heart rate. This has to do with how fit you are and your maximum heart rate, which for adults is about 220 beats per minute, minus your age. If you are not fit, the rate will not be the one that is expected.
The top number, known as systolic, refers to the amount of pressure in your arteries during the contraction of your heart muscle. The bottom number, known as diastolic, refers to the blood pressure when your heart muscle is between beats. So, in the graph, the systolic value is 140 because of the sum of the 115 plus the amplitude of 25, being located in the highest point of the graph. Then the diastolic value is 90 because of the subtraction between 115 minus the amplitude of 25, being located as the lowest point of the graph.
Another application for this topic could be in music. Musicians have terms that they use to describe tones. In this case, a term could be a sound with pitch. This kind of regular, evenly spaced wave is useful for things other than music. However, scientists and engineers also use them to describe pitched sound waves which determine the tone of a song.
In this project, we learn different things about the use of the sine function. For example, in the graph, we can see that mathematics is related with other fields in life, such as physics, music, etc. In this case, it is related with medicine, in which just by seeing the graph we could know the different values of the heart blood pressure, having as a conclusion that mathematics is something important to know and apply in other fields in life.